Hello, can you guys let me know if the sound is clear? Can you hear me clearly? Awesome, great. Thanks for the feedback. All right, so let's get started then. Put on. Hello, now you can see me. So welcome everybody. Thank you for joining another Worth webinar. It's the first one in 2021, and hopefully we'll do a lot more of these during the coming year. So today's topic is the deployment pipeline pattern, and I'm going to talk a little bit about why the word pattern is there and why it's important. But first, a slight detour. If you couldn't read it clearly, I'm going to take off the picture-in-picture so you can read the subtitle. It says, a pipeline does not equal CI/CD. So before I get into the pattern itself, I want to take a slight detour on exactly that topic. Let me turn on my speaker notes. Put them here. Screen. All right. So, continuous integration, so that's what CI stands for, is a practice. And continuous delivery is a whole set of practices, right? So there's a book, Continuous Delivery. If you haven't bought it, buy it, it's great. And continuous integration is mentioned in many, many books, including the Continuous Delivery book, which is sort of a set of practices and methodologies. So continuous integration really simply is just exactly what the name suggests. You continuously integrate. So integrating meaning you're taking new features, putting it on top of the existing code base and testing whether it still works, and you're going to try to iterate as quickly as possible. And continuous delivery includes continuous integration as a practice, but also includes other things which are more broad, such as configuration management, automated testing, automated building, automated deploy. And there's also a lot of talk about managing all these processes. So how does an organization manage teams that practice continuous delivery and practice all these practices? There's the word practice many times in a row. By the way, in the meantime, if you have any questions during the talk, please put them in the chat and I'll try to work them into the presentation. So I guess this is kind of what it boils down to, the point I wanted to make before I go into the deployment pipeline pattern, which is many times I've heard people saying we have a CI/CD pipeline, but it's not CI/CD in itself maybe doesn't say so much, and even saying we have it, also a little bit confusing, because if anything, you do continuous integration and you do continuous delivery, which is actually pretty big thing to claim because there's a lot of it, there's a lot to it. So maybe just trying to put it out there that you need to be a little bit more precise when you say these things. And when you say we have a CI/CD pipeline, maybe what you should be saying is we have a deployment pipeline, but even then, a deployment pipeline is a very specific thing. Another thing, well, we've all heard people say it, we should hire a DevOps. Right? DevOps, like continuous delivery, is more a set of practices, a set of a philosophy almost on how to do software development. So saying we should hire a DevOps, that's a bit of a misnomer. As you know, inside Worth, I'm a big promoter of using the term site reliability engineer, which is something that's also a term used at Google. That's what they call their DevOps engineers at Google. The idea that we should use a different name for me is also based a lot on a little sort of psychological trick that this might do, is if you say this is a DevOps engineer, you may also start thinking, oh, if we have a DevOps engineer, we can do DevOps, which it's a much broader thing. It's a much broader set of practices. So you don't easily get away with just hiring somebody and then all of a sudden you do DevOps. So now to the meat of the talk. The talk is actually about this. well, maybe it was about the thing in the previous first slides, but this is also the core topic, at least the thing that's in the title. A deployment pipeline is a well-defined pattern. Now, why do I underline well-defined? Because when I hear people say the pipeline, it isn't clear to me that they mean this. It just means we have a build server and there's a bunch of steps, but does it qualify as a deployment pipeline? Does it tick all the boxes defined in this pattern? Well, probably not all of them, maybe some of them, maybe most of them, but in any case, I want to go back and look at the theory about deployment pipeline and really discuss that a little bit in more detail so that you can compare it to what it is that you think a pipeline is, see what the differences is, and in the future when you say deployment pipeline, you could maybe add into it, well, we're doing deployment pipeline a little bit differently, or we're saying deployment pipeline is actually fully as defined in DevOps. So it's again, I'm a very big believer in communicating very clearly what this is, or what it is you talk about. And pattern, well, we all know what design patterns are, right? A pattern is a name for a solution to a common problem. So in design patterns, something like a visitor pattern, a factory pattern, a command pattern, those are, or command objects, command classes, those are names of patterns, which if you use them in conversations with other developers or other engineers, if they know that pattern, you can save a lot of communication because you know exactly what you're talking about. So again, if you start using the word pipeline to mean this vague concept of sequential steps of build and test and whatever, and there's actually a little bit more nuance to it, then it messes up that communication because you can start getting confused as to what somebody means. So really high level before we go into the pattern itself, what a deployment pipeline does is high level these 5 things. You build the code, you test the code, you do code analysis, which could be things like looking for common programming errors, or a linter, which looks for style things. You package the thing that you built, and then you deploy it to some environment, or environments plural. Now, when does a pipeline perform well? Well, when it's fast, efficient, meaning resource consumption-wise, and also to a degree speed. Important that it's reproducible. So if the pipeline runs against a specific version of the code base, a specific branch or a commit ID, if you run it once or twice, hopefully the behavior will be exactly the same. There won't be random failures, which you sometimes see in end-to-end testing or UI-driven tests, where sometimes they're failing randomly. So these are all properties of a good pipeline. It's reliable, it's informative. So again, the feedback loop, which is something that's really big in well, almost any methodology nowadays, any type of agile, continuous delivery, DevOps, is all about getting that feedback quickly. So let's decompose the pattern. Let's dive into detail. I took a picture of a diagram in the continuous delivery book. And so you can even see the text on the next page. The reason why I didn't just use a picture I found on the internet is because the picture in the book actually covers it, I think, the best of all the visualizations I found. So I wanted to use that. And since I couldn't find a digital version, I just took a picture of it. Hopefully it's readable. I also took the time to create some animations so that we can go step through all of the aspects of the deployment pipeline from beginning to end. So let's go. We'll start in the top left. So at the top of the diagram, you see this bar called version control. That's where the source code lives. No big surprise, we have code repository, and there's some type of integration, whether it's a GitHub webhook or a GitHub action, or maybe if it's a Jenkins server, sometimes you can even do polling, which it polls every couple of minutes to see if there's new code. In some way, new code triggers what is called the commit stage. The commit stage does several things. It compiles the code, which could be also something like transpiling from TypeScript to JavaScript, any transformation that is required before the code runs. Then there's this term commit tests. What they mean here is it's not that we're testing a commit specifically, or the reason why they don't say unit tests is because all they really care about is these are the tests you run on each commit. On each commit, this stuff runs, and it needs to pass, right? It's something that happens, it's the quickest set of tests that you have. And whatever you want to call those, component tests, integration tests, doesn't matter, they're the ones that run each commit. You then assemble something, whether it's a zip file or a jar file or anything, you package it, you apply code analysis, which again, these might be linters, SonarQube, those types of things. And in the end, the reports, the binaries and metadata get stored in an artifact repository. So an artifact repository is anywhere where you can store files. Could be something like a Nexus artifact repository. It could be a container registry if you're working with containers. It might be just an S3 bucket on AWS. It could be anything, but you just store the stuff there so that it can be used later. So far, what I've described is pretty much any pipeline software that you use works at least in these steps, and nothing's odd, right? You shouldn't be surprised by what you're hearing. But now comes something interesting, which is the split between the first two steps of the pipeline, which I don't think all pipelines have, or at least not all the ones I've seen, and it's not super common to have a specifically named acceptance stage. So maybe you use a different name and you do have it. I'm not saying that it's always called this, but sometimes it's a separate step, but it's not something that runs automatically after the commit stage, nor is it a required step to pass for the whole deployment, right? So in the deployment pipeline pattern, the first fat arrow that goes from commit stage to acceptance stage, that's an automatic process, right? So things that pass through the commit stage successfully automatically go into the acceptance stage. So what happens there, the first three steps are actually shared across all of the stages after commit stage. Those three steps include everything you need to do according to the deployment pipeline if you do a deployment. So the acceptance stage starts with the deployment. You configure an environment, which may be anything from taking the artifact and injecting stuff into it, like mutating configuration files, properties files before a deployment. Or configuration might also be something like if you're using a key storage or secure key storage in your deployment target. So if it's AWS or Azure, you'll put the configuration there so that it ends up in environment variables in some way when the application runs. You then deploy the binaries. Simple step, we always do that. And then smoke tests. This is something that, again, in my opinion, is pretty uncommon. I haven't seen a lot of people using smoke tests to really quickly check whether your deployment was successful. So it's not so much the functionality that you're testing, even though you do use the functionality to verify that the deployment was successful. What you're more interested in is just a quick check to see, a sanity check. Do all the integrations work? Can I reach the database? Can I, if I have another external integration, can I reach that API? So that's a smoke test. And then there's the acceptance test. The acceptance test, obviously, is the reason why it's called the acceptance stage. These are functional acceptance tests. Very often people call these end-to-end tests, but those things aren't necessarily the same. We're testing functionality in a real environment, because that's why we deployed everything. We deployed it to a real environment, realistic in any case. And we're checking whether all the functionality works. So once that happens, you can see an arrow from that stage down to the artifact repository, because the output of the tests might be a report, which you also want to store somewhere in a repository for review at a later date. So again, it's the same artifact repository, or it doesn't have to be the same, but it's stored somewhere. It's persisted somewhere. So another part of the deployment pipeline pattern is that environment and application configuration comes from version control. So again, this is configuration management. This means infrastructure as code, configuration as code. You want to see version control on all of these artifacts so that you can see the change over time and you can manage the update process. And it also makes things like disaster recovery a lot easier to put all those things in code. And then finally, those two blue arrows, I overlaid two blue arrows on top of the first two arrows that go from left to right. Those steps are automatic. So you go from commit stage. If that succeeds, you go to acceptance stage. If that succeeds, you go to capacity testing. Capacity testing, the capacity stage is the same as the acceptance stage, except you run capacity tests instead of acceptance tests. So capacity stage is, again, something not common practice. It's part of the deployment pipeline, right? I mean, the pattern doesn't mandate that you do this, but it is part of it, right? So when you think about what do we do in our pipeline, do we have performance tests? And do they run in this fashion? Do they run after acceptance tests in an automated way as a separate, distinct step? And the last thing I want to point out in this diagram is look at the roles. You see developers. Those are active when the commit stage and acceptance stages run. They are involved in receiving the feedback from the pipeline. If the tests fail, they get told. And they're basically in charge or constantly involved in that process. And then the user group that goes from acceptance stage to UAT, which stands for user acceptance tests. The testers are responsible for self-service deployments and manual testing on an acceptance environment. So you can imagine if you have a release process where the testers need to manually verify that something still works before a deployment, they can self-service deploy to an environment. Hopefully that's an environment that's stable, that they can deploy to and own for a while, as long as they do their testing, and it's not an environment where other people are deploying into without their knowledge, right? So you want to at least have some guarantee that when they self-service deploy to UAT, that they own that environment. Similarly, for a production deployment, the operations, ops, whoever that is, that might be part of the team, it might not be, it depends how your organization is organized. They will just press a button to deploy, right? Somebody maybe reads the change log and says, looks good to me, and then boom. All right, what's next? What I want to go over is the why behind all of these parts. So we decomposed the pattern, we looked at all the details, what constitutes a deployment pipeline as defined by the DevOps pattern. I want to ask why for each of these. Because I think it's important to kind of understand the why, because then when you understand the why, it's okay to deviate if it doesn't fit your situation and you avoid cargo culting things and doing them incorrectly. So I think for version control, no need to spend a lot of time there. I think all developers, everybody's more or less in agreement why they do this. Why is version control a good idea? Not just for code, right? But also for infrastructure and for configuration, right? It's about historical traceability. You want to be able to see what's changed, and especially if you need to reproduce something, like I want this thing that we tested on this environment, I want the identical stuff on this other environment because I want to use environment A, or I need more time to figure something out, so I'm going to deploy it. I want it to be exactly the same. Schema changes. I want, if possible, the data to be the same as well, the database. So as much of that stuff in version control as possible is a good idea because it improves your reproducibility. And I'll wrap this up in the end by basically saying that it's all about automation and reproducibility. At least this pattern is, not everything, but I mean, this pattern is all about reproducibility. Why an automated build? Again, why automate anything? Because you want to eliminate human error. You don't want somebody to have to do that manually, and maybe that person gets hit by a bus, or becomes senile and forgets how to do it. Like, you don't want that fragility in your process. And also, I think the first point, this is something, I like this sentence a lot. I like it as a credo. If a human can do it, if a computer can do it, a computer should do it. The reason why I like that is because it's something, I think Uncle Bob said something like this, where it's almost unethical to ask somebody to do something repetitive that you could potentially automate. You're asking somebody to kind of do this soul-deadening activity of doing the same thing over and over, like a test script. Like a lot of test scripts ask you to just read what it says and then do it on the screen, and you have to do each step, even though most of that stuff could potentially be automated. So why automate a build? I think a lot of this is obvious, so no need to spend a lot of time on it. Now, this is maybe a little bit more involved. Why a single artifact repository? Well, I mean, a single artifact repository, the reason why I put single there is because I've recently seen situations where if you're using Kubernetes as a deployment platform or as a runtime platform, you need to fetch container images from somewhere, right? A container registry, and it's common to see container registries created as a resource in itself in the same environment as where the cluster exists that it needs to run on, right? So if let's say each environment you have dev, test, acceptance, production has its own cluster, sometimes they get their own container registry. And the reason why that might not be the greatest idea is because part of the deployment pipeline pattern, or at least the best practice around the deployment pipeline pattern, is build your artifact once and only once. Because any rebuild of the artifact might introduce changes, and you want to eliminate, if things go wrong, you want to eliminate as much as possible the changes. You want to be able to identify what could have broken your application, and you want that surface area to be as small as possible. Again, in the spirit of DevOps, working in small batches. So part of that is build your artifact only once and deploy it multiple times. There's obviously also a small speed benefit. If your build takes time, you don't have to do that multiple times. If you've ever worked with Travis CI or something like Bitbucket pipelines, by default, a lot of examples show you a build and then deploy as a single step. And artifact doesn't necessarily get stored unless you add a plugin or do something extra. But by default, it seems like, oh, you build and deploy in a single step, which means you don't store the artifact, right? So there's no artifact repository to put your reports, which from the point of view of Travis CI, I get that, because then they don't have to care so much about where to store artifacts. They don't need to provide terabytes, petabytes of storage space for open source projects that build many artifacts per day, perhaps. So obviously, these technologies do support the storage of artifacts, but these are usually plugged in. They don't do it out of the box. Why split it into two phases? So I spent a lot of time explaining that the commit stage is something separate that starts and finishes before an acceptance stage, which then is separate and starts and finishes before a capacity stage. Why split it, at least the first two steps? Why split it into three technically stages? I think the main reason, as it is explained in the theory at least, is each step gives you valuable feedback. And you want each step to finish as soon as possible. So if you want your commit stage to give you feedback as soon as possible, it makes sense to take this, generally speaking, slow deployment and slow acceptance test and put that into a next step. Also, if let's say the acceptance stage fails, you might still want to store the artifact, right? So it's nice to have this the atomic nature of each stage. It either passes or fails all at once, all together. So if something passes the commit stage, you also always want to store the artifact somehow, right? So separating those two things is a good idea. Also talked about why every deployment contains all three of these steps. You configure the environment, you deploy the binaries, and you do a smoke test. It's really deploying the same way to each environment is a big best practice in DevOps and continuous delivery. So you need to eliminate change. Like I said, this is all. I'm basically spoiling the end of the talk because it's all about reproducibility. It's about making sure that everything happens the exact same way each time, so that the only thing that's different is your code. If the only thing that's different is your code, then if it breaks, you know where to look. Right? You don't want to spend time looking at logs like, why is this environment different than the other? Right? That's why you automate. Store an app. Why store app and infrastructure in version control? Well, we have already covered version control as a more general thing for configuration management. But I also want to emphasize in this particular slide that, again, the reproducibility is core to all of this, where you can imagine that if somebody deploys manually or configures a system manually, where I used to work at a company that worked that way, and we would log into each machine, and I'm almost embarrassed to say this, but I mean, it wasn't my decision, so the company decided to do it this way. We would log into the machine, it was a Windows machine, and then somebody would unzip an archive that I made. I had to show up for a deployment that I was responsible for, right? So everybody that had a deployment that they were responsible for would show up at 5 o'clock in the morning. They would unzip the archive. They would read the instructions. I'm sitting right next to the guy, but he's reading the instructions because that's the protocol. He doesn't want to ask me. He doesn't want to need to ask me any questions. And then he copies files over one by one. And then he does that per server. Right? I'm there to point out any mistakes. So there is some control. There's some quality control. I'm the developer that knows how to fix things. So, but it's so error prone that configuration drift is a fact. Like, it's unavoidable. Somebody's going to do something that's slightly different on one machine than the other. So those two machines are going to slowly drift apart, where they're so different at some point that it's likely that a deployment on one will fail for a reason that's very different than another server where it may have succeeded. Self-service deployments. So there's a step in the deployment pipeline where testers deploy when they decide to an environment, usually user acceptance test environment, a UAT environment. So this isn't a hard requirement by the pattern. I mean, if you read the text, they say, well, you may do this, so you don't necessarily have to. You might actually have a situation where there are no manual testing steps, right? So in such a situation, something like this wouldn't be needed. But most of the time, you do have manual exploratory testing. And because it's self-service, somebody chooses when it happens. Ideally, their environment is isolated from other people, and it doesn't happen automatic, so that if a programmer has a new change, it doesn't override what they were testing. They know that it's the thing that they chose to deploy is being tested and nothing else. Again, reproducibility. Again, why do the ops guys push to deploy? Well, it's not actually mandated by the pattern. You can imagine, again, you don't have this step. You do continuous delivery plus continuous deployment, right? You're constantly deploying in an automated fashion. You have such high confidence that your automated tests catch bugs that you've convinced the customer we can actually go straight to production when the tests pass, because we haven't had a bug in I don't know how many releases, or at least nothing serious. So the reason why it's pushed to deploy is because you want the step, if it exists, to be as lightweight as possible. So there's a bunch of things which some of which I've already talked about, which are sort of adjacent to the deployment pipeline pattern. They're not in the pattern. But if you read any DevOps book or any DevOps collection or something that describes DevOps holistically, all of these things connect. The deployment pipeline pattern doesn't exist in isolation. So some of these things will make logical sense if you combine them with the pattern. The first of which is continuous integration, right? So continuous integration doesn't require a deployment pipeline. So if you read the Extreme Programming book, they'll talk about having an integration machine, right? Somebody goes to the machine and integrates their changes, and because integration can or should only happen on that machine, yeah, only one change can be integrated at a time, so the parallelism goes away. Plus, it's a resource lock. So if somebody else wants to integrate their changes, and that guy's been integrating for 2 hours and he hasn't been able to do it successfully, then the whole team will be aligned in doing one thing at a time, integrating only what's successful, and when all the tests have passed, only then do we continue on to integrating the next thing. So continuous integration with a pipeline works better because all of that stuff is automated and reproducible thanks to the tests and all of the other types of automation, but it's not required. Trunk-based development, if you don't do it, you can still have a deployment pipeline. All of those steps could still work if you have an integration branch or if you have feature branches that you want to deploy. You could still do almost everything in that deployment pipeline, if not everything, but trunk-based development sort of makes more sense. There's this, again, if you read a book or you go to the Google DevOps website, all of these practices underneath listed together make sense in combination, and trunk-based development is one of them. Feature flags sort of goes together with trunk-based development. You want to be able to push things through the pipeline and deploy them dark, right? Not have them be active. That makes it easier to do continuous integration. Size of deployments, again, some of it is part of the deployment pipeline, but really you could still screw up, right? You could still decide to have long-lived branches and to have huge releases with a lot of changes at once. So the deployment pipeline doesn't help you keep batch size small, but it makes sense to do it, right? Because all of this is automated. Why wouldn't you try to do as small a change as possible? Because again, you're reducing the surface area that you need to search for bugs in. If something goes wrong, if you made a mistake, the change is small, it's easier to find. Everything else is automated, so you don't have to look at how things are built. You don't have to look at how something is tested. You don't have to look at how something is deployed, because that is the same every step. It's automated. So I think I can skip a lot of these. You can have a look at any DevOps source and see that all of these patterns or practices hook into the deployment pipeline but aren't necessarily mandated by it. I do want to spend a little bit of time on number 7, which is on-demand environments. So it turns out from statistical research, if you guys are familiar with the DORA DevOps research, they've had 60,000 people fill in a form explaining their process and all their practices. And it turns out that on-demand environments in and of themselves don't predict high performance. So they've looked at organizations, they've categorized them from low to high performers, and it turns out that if you do just on-demand environments, meaning I can create an environment for myself as a developer or as a tester, and it's mine alone, that in itself doesn't improve performance of the team and of the software delivery process, only if combined with other things. So if you have a deployment pipeline and you're doing continuous integration, adding this on top will improve your performance, but just having this doesn't really help you so much. Okay, so as I've spoiled several times, the point I want to make, one of the big points I want to make in this presentation is this. So it's about dealing with change over time, and humans are really bad at that, right? We're forgetful. Whenever we do something, we do it slightly different each time. There's a lot of reasons why automation makes up for all of our human shortcomings, right? So the deployment pipeline and a lot of the DevOps practices are there to fix this, this shortcoming in humans that we can't really deal with changes over time very well, right? You're writing code, but then you have to consider, oh, on production, there's slightly different data. I have to migrate that data. Yeah, there's so much to think about. You want to automate and offload as much of that as possible. That's kind of what the deployment pipeline is about in its core. It's about reproducibility and taking the work out of our hands. So automation is about controlled change, right? That's kind of like the conclusion, I think. Deployment pipeline is about automation, and automation is about controlling change. And change is the big thing, right? In maintainability, in software quality, all of that. So, we've reached the end, and I'm very curious if you've read anything about DevOps, or maybe this is the first you've heard of all these patterns, or at least the specific pattern. What does that make you think of when you look at your own project's pipeline? Do you see things missing? Do you see that you do things better? Does it make you think about anything? If you have any comments, please, I would be very happy if you put them in the chat. We can maybe have a short chat about them, a short discussion. But as far as the presentation is concerned, it's over. So if you have questions, please put them in the chat, and I can take some questions now. So it's eerily quiet. It's okay. You don't have to. We could cut it short. We're 20 minutes early. Well, I wanted this not to be too long, because the previous webinars were a bit on the long side, so I wanted to keep it short this time. I did. I managed it. So if you guys want to fill it up with questions, that's good. If not, we can leave it at that. I'll give it a few more seconds to see if anything trickles in. Thanks, Eimer. All right, well, I guess I'll just leave it at that, and thank you all again for joining. At the peak, I think we had 27 viewers, which I'm very happy about. I think that's a new record for my webinar, so super happy about that. Thanks, everybody, and hopefully it won't be too long until we have the next one. And here, now you can see all of me. Yeah, thanks again. Talk to you guys soon-ish.